I wanted to take a moment first to thank the organizers for having us present. I think it's quite appropriate that we present on the third day, since we are really an end case user of ontologies. And I think it's also been sort of fascinating to hear over the past 2 days the types of, as ontology novices, the types of challenges that we are dealing with are really challenges that I still hear in the meeting being presented by others. So just to take a minute, I'd like to spend some time on this slide to set us up for understanding our story and our case study here. So we really, as a distal ontology consumer, Eurofins Discovery is a life sciences products and services contract research organization. So that means that companies, whether they are startups, small biotechs, large pharma, academics, or even government agencies such as the EPA and National Institutes of Allergy and Infectious Disease, come to us for help with their drug development and discovery issues. And today, I'm going to tell the story of sort of 3 team members that really have not interacted much before, but on this project, we certainly have. So that's Amy, myself, and Antal, who you see here as well. Amy is our business development manager. She manages the e-marketplaces. So these are online clearinghouses, basically, where clients will go and enter in their search term that they think describes the assay, the bioassay that they're interested in, or other keywords, and hopefully they will be served up the appropriate assay that we offer. Now, there are other companies such as Fisher and other CROs that are on these marketplaces. So Amy's real interest is making sure, first of all, that customers understand what we offer and are entering terms that we associate with our assays, and also to increase, the company visibility and sales. And then my role really in content strategy is to really harmonize all of our content across different forms, which includes these marketplaces. It includes white papers that we write, web pages that we have, and to make sure that the terms that we're using are similar across all of these forums, and that people can find our information and use that information to educate themselves about our products and services, and then ultimately, of course, come to us for their needs. Antal, as the 3rd member of this team now, as an informatics scientist, and his goals are along team member efficiencies and their use and of data within the organization. So just to further the point of the e-marketplaces, which is really the focus of this particular case study and story, on the right, you can see a list of terms that were given to us by one of the marketplaces. They gave us a list of about 1,500 terms that we needed to then manually curate to eliminate terms that were irrelevant to assays and services that Eurofins does not provide, and to make sure that the marketplace was populated under our particular profile with terms that are relevant for our assays. And the color coding here is just describes these 6 different employees, contributors, which were product and content managers of the different business lines, and what they thought and selected based on their subject matter expertise would be relevant terms. So you can see there are quite a few irrelevant terms. So this was quite a tedious task, and it ended up leaving us with about 500, just over 500 terms that were relevant for Eurofins Discovery on this online marketplace. Now, unfortunately, fortunately for us, there are more than one marketplace, but unfortunately for us, they don't use the same terms to describe the assays. So we received a second list, independent pool of 5,000 terms. And that's when our eyeballs kind of started to roll, and we thought, how can we really reduce the manual labor in this curation effort And how can we make sure that we're obtaining only highly relevant results? And also importantly, that we're not missing important terms. So somebody might search for some cell type assay or in vitro service that we haven't indicated as associated with one of our assays. And we don't want this to happen, but a competitor would pop up as a result and we would not. So I came, with this problem to my colleague Antal, and he said, use an ontology. And we said, okay, great. Which one do we use? So we found that there were about 900 ontologies that are related to biomedical sciences. And perhaps we felt that, just like standards proliferate and people develop their own, we sort of felt like the same thing was happening in the ontologies. So we decided, well, maybe we should search this repository. So we picked two particular keywords that are highly important to our division, which are cell-based assays and phenotypic assays. And in searching this repository of biomedical ontologies, we were fed a result of about 20 to 30 different ontologies, including the bioassay ontology, SNOMET clinical trials, and Go+. Okay, this was a good result, but again, a little too many ontologies for us as ontology novices to know where to go from there. And then Antal said, well, let's use a mapping tool. So we looked at OXO, and I think we were attracted to this as a mapping tool because in the description, it says that it finds cross-references based also on ontologies, but also on vocabularies. And we had a vocabulary of over 500 terms. So what we did was enter our vocabulary, and surprisingly and somewhat disappointingly, were returned only two terms in our list returned ontologies. So those terms were cosmetic and inflammatory response, and the corresponding ontologies you can see here, Chebe and the gene ontology. So our big challenge is that, finding the correct ontology is really challenging for us as a distal end user. And our ultimate goal is to contribute our own assay data to an ontology that we find helpful. So this is really important for us to get right. So we thought, well, we have a bit of a Goldilocks dilemma here. One result was too few, one result was too many. So perhaps to get what's just right, we should establish our own search criteria. So we developed 3 criteria that were based on really the biology of what we offer and the users. So these would be the terms and classes such as cell-based assays, and also that it should be fit for commercial purposes. Not more along the lines of a clinical type of ontology. The terms in the ontology should be complex. Eurofins Discovery is a large CRO. That's why people like working with us, but it means that we do have a very large list of terms to cover the breadth of our offerings. And also we wanted the ontology to be maintained so that for end users like us, we would have someone to go to for questions and answers, for suggestions, and also we want it to be currently maintained. This, led us down a project which was really interesting, but it was minimally helpful in us getting our work done. And just to remind and describe more about what that work was, so we had this simple task, which was accurately matching these 500 terms from one ontology or one electronic marketplace to another, which is with a much larger list of terms. So on the left here, you see some of the sample terms that we were trying to match and some of the complexity of these terms. So the first two, affinity tag purification and affinity binding assays, they start out the same, but then they differ. We have terms that have the same words in a different order, for example, inflammation assays and then assays for inflammation. We want all of these to hit and none of them to miss. So in thinking about this, Antal, we thought about how long, what it actually is this task. And it turns out that it's about 2.5 million pairwise comparisons just by eyeballing it. And Antal did the math. So if we do 1 pair per second, that's about 30 days of nonstop matching by eyeball. So this is where Antal comes in, because we definitely needed a more analytical approach. So Antal, I'll flip it over to you.
Thank you, Sheryl, and thank you for inviting us. We're fairly new to ontologies, and you know, really so many talks are showing the way in this space. So I've been a data engineer at European Discovery. I've been working on limb systems and analysis automation for about 10 years. And current projects include compound information management and machine learning. And its ontology falls into this space. And it's really close to my heart, because every time somebody says ontology, they think they're talking about me. So in software engineering, when you start designing a system from scratch, you start defining variables and develop a data dictionary. And it seems that it works when you have a closed system, but when you work with several systems, they don't translate really well, or they don't map from one to the other. So I was really intrigued when Sheryl approached me with this problem of matching lists of vocabulary terms. And yeah, so a quick analysis showed that even if you have chrome-plated eyeballs, it's going to take a long time. And so I was turning to think about solutions, and here I'm going to present an increasing order of increasing usefulness, some that worked and some that didn't work for us. And it was a quick and dirty project that you could do in a few days, because we have deadlines. So we didn't have it's not a very polished approach, but I'm going to dive underwater here. And so I'm going to present eyeballing, which actually Sheryl mentioned that it takes just a very long and painful process. And then tried as a simplest approach, Excel, which has the function VLOOKUP, which can do exact matches and approximate matches, and then turns to natural language processing in Python, and tries to use 2 different metrics to match terms. One is called Levenshtein distance, and the other one is cosine similarity. And like next slide, thanks. So a better approach than eyeballs. Excel has options to match terms exactly, which it does really well, and it's very easy. You can get it done in a matter of minutes. But our terms weren't exact matches, and approximate matches only looks at, it turns out, only looks at characters at the beginning of words. So catapult and caterpillar will be flagged as matches without any further metric for how closely they are matched or how good the matches are. They're just listed. So in cases where there are a few exact matches, Excel doesn't help much. The next slide. So this is a demonstration of the approximate matches produced by Excel, which is easy to do, but doesn't give you very good results. For example, bioequivalent studies will match up with biodistribution studies, and biomap, human phenotypic platform, will be matched with biology, which is broadly true, but not very useful. So next slide, please. Thank you. So then an even better approach would be computational string comparison. Comparing words, phrases, terms in computer science collectively called strings is a non-trivial task. Finding exact match is easy, but finding a degree of similarity to guide the curators is more difficult. Because a single change in a character can signal a small or a large difference in meaning. For example, assay and assays have similar meaning, and 3D and 2D cell culture, although look very different, but have very different implication on what kind of science you can do, what kind of assays you can do with it. And also apparently different strings can carry the same meaning, like human and Homo sapiens. And we didn't have enough contextual information to go do context sensitive searches. So I didn't use it. So various metrics have been developed to measure similarity between terms. And so we used Levenshtein distance and cosine similarity to compare the words and terms in the two listings and rank them. So next slide, please. So Levenshtein distance is the minimum number of single character edits, insertions, deletions, or substitutions required to change one word into another. For example, to go from kitten to sitting would be step 1. You substitute S for K and substitute I for E, and you insert G. So there is no way to accomplish this in fewer steps. So the minimum distance is C, and you have a sitting kitten there, which is not a kitten. That's the joke. And this is the result, like a sample result for matching the query term in the first column, the matches in the second column, and the similarity in the third column. So you can see again that deceivingly short distances are actually quite large in meaning. So that was not a very useful way to compare this here. So come in the second metric, cosine similarity, which is probably more widespread in natural language processing circles. So on the diagram, you can see if you have a corpus of documents, in this case, we had like 500 or 5,000 words, you make each word into a dimension along an axis. And in this case, you have a corpus of 3, then you would build word vectors from high and world would be one, the red vector, and hello and world would be another vector. So what's left is measure this angle in purple, take the cosine of it, and that gives you a similarity between two strings or two phrases. So we measured it in S, it's measured in the range from 0 to 1. And if it was 1, it was an exact match. An approximate match, we said if it was between 1 and 0.5, we would call it approximate match. And we would say there is no match. If less than half of the words matched, then it would label it as no match. The next slide is talking about how we actually did the work. They used Python. The sklearn package contains algorithms for the necessary coding. It can do vectorizing, turn words into vectors. It can do the cosine similarity. It can do ranking. And I found this article by Dario Radecic, I hope I pronounced his name right, that basically laid out this workflow. So it's a typical NLP, or natural language processing workflow. So read the words from the data files, remove stop words like and, of, a, the, punctuation, remove punctuations, lowercase it, vectorize the words. Then comes the meat and potatoes of actually calculating the similarity, rank the results, format the output, and hand the results to expert eyes like Sheryl to evaluate. On the next slide, we'll show the outputs of the similarity search. Again, the first column contains the search terms. The second one is the matching term from the second corpus, second listing. And the third column shows you the closest match with the degree of similarity. And it's formatted in Excel. So it's a conditional formatting. And the bar shows you, so it's visually apparent which one is a better match. So first you would look down on the result, the first column, the best match. And if there was something wild that came up, then you could look across and look at the second best match. So you can look first down and second right. So this basically reduced the problem from an input space of n times n, or from 2.5 million to n. You still have to have expert eyes, but instead of looking at 2.5 million, you look at 500 terms, 500 pairs, maybe a little bit more, but it's the order is reduced. So some approximate matches highlighted here to illustrate that it's actually doing a surprisingly good job. I was surprised. LC-SM analysis was matched with LC-MS with 0.7. And multi-drug resistance was matched with multi-drug resistance MDR testing. DNA mutagenesis, even though the words are not exactly matched, there are some additions and insertions, it still falls into the good match or approximate match, and it's workable. So out of the 522 terms, about 20% we had exact matches, 60% fell into the approximate match, and 20% weren't very good matches at all. So about 80% of the matches were done this way. So 80% of roughly the work. So next slide, please.
I think this is where we're going to switch again.
Oh, yes, back to Sheryl. Thank you.
So this was the outcome we had. We just want to call out that it was with this particular group that we started with, curating the list of 523. You can imagine if we had scientists, product managers with slightly different expertise who were choosing different words in that initial list, as we go down the road in this project, we would end up with a different list here. So where are we now? You know, as users, I think we're still kind of circled back to the beginning. We understand that this is really a challenging project to find the correct ontology. What we did learn, though, however, is that there are really many biomedical ontologies, in particular for cellular assays. That's also true. Excel, of course, is excellent for matching exact, but poorly matches anything beyond that. This cosine similarity seems to work well for approximate matches. And very importantly, though, and this I heard in some of the talks earlier, people are really still needed for curation. So as a particular example, we had a key term for us, which is phenotypic screening, which was missing from that list of 5,000 terms. It's kind of hard to imagine with that many terms that this was not present. So we added that. And then from the cosine similarity result, there were still irrelevant terms, which turned out to be about 12% irrelevant that were included by that scoring method. So manually we curated through those and had to remove those. Then we were thinking, perhaps we could have used a different ontology mapping tool at the very beginning to help us. But as Antal mentioned, we really had a short time frame and resources to complete this project. It's really not our day jobs. And we have very little expertise with ontologies. And although there are these free mapping tools online, at least the terms we worked with, we think, were not encompassed by any ontology. And I would like to thank Amy Allen, who is our e-marketplace manager, Jennifer Drake, and Ellen Berg, of course, for contributing with Antal and I on this project. And we just wanted to leave this up for any discussion time. What if all these categories and terms were really equally understood by contributors of diverse backgrounds? And what if these e-marketplaces themselves were educated about ontologies? And what if they would be the ones that would establish adherence to ontologies, and we as end users could just go in and upload and make sure that we're using what they've all established. And then, of course, importantly, for content and content strategy and content marketing, what if these terms were harmonized across these different platforms beyond these e-marketplaces, such as the assay descriptions themselves and web content, and then also for example, white paper, file properties, and keyword tags. wouldn't that be an easy place to be?
That would be certainly ideal. Thank you so much for your presentation, both. I'm sorry I forgot to introduce Antal, who is a data engineer at Eurofins, and he's 18 years experience in Java and SQL, and it seems like you're getting into new languages and new platforms, Antal. So I have a lot of questions for you. I'm going to quickly try to go over the one question that got a lot of upvotes. So Tom Walpole said that I'm curious to hear what vectorization techniques you found the most success with, transformers or word-to-vec, and what dimensionality reduction techniques, if any, used as a part of your similarity comparison. If you think that this is going to be a very long answer, you're also welcome to give us the short version and complete on the document, because I have other questions for Sheryl as well.
Yeah, so very briefly, I used the feature extraction package, sklearn feature extraction. I posted it in the chat, count vectorizer, and I didn't use any dimensionality reduction other than removing stop words. So that was, I mean, that was, I could have removed words like assay, but I just let the vectorizer handle it, and it did, I think, a good enough job, like 80% of the work with 20% of the effort. So
thank you, Antal. Thanks so much. And there are a couple of comments about the scope of BAO, which includes some of the assays that you mentioned, and I have a question about your annotation efforts, and because that's one of the main uses for ontology is annotating the data, and your background in publication and now at Eurofins, and I know Ellen and I were in a panel last year, so I know that you guys are already ahead of the curve in that, but I'm wondering, what do you think about data generation and better data generation? How do you see the ontologies and your efforts kind of mixing together, and even publications, if you're happy to?
Yeah, absolutely. So, there are all the data standards that are out there for trying to harmonize, the way people even submit, their data to the FDA for review. Certainly the ontologies could tie in, in this respect.
Yeah. Do you think that tools for at least making curators' lives easier, and helping them evolve the ontologies faster too in the process, because mappings and adding new terms has been one of the themes of this workshop. So I guess I'm wondering, what's the learning curve for curators? And
yeah, I think it's pretty steep. I was kind of shocked at how, I mean, we really are novices and really went into this blind. But working with Antal made even the progress that we made possible. So there really should be some sort of effort to have even some like basic training, or a basic hub where people like myself who know nothing and just want to be able to use, and then ultimately Eurofins wants to contribute to an ontology with our work. So the first step is using one and seeing how it functions, so that we know where we go from there. But I think we're not even there yet.
Yeah, the industry and in the ontology community have different ways to go, I think. So, but there's a lot of effort to be for this. Thank you so much.